All right, everybody, welcome to our first log and exponential lesson. This is unit 5.1. We are solving all types of log equations today. Okay, so the first thing that we want to talk about are properties of logs. So we can condense and expand logs in three ways. Okay, the first is the product property. So if you have a times b that you're taking the log of, you can split apart those two values into separate logs and they become addition. Okay, and along the same lines is the quotient property. So if you are dividing two values in a single log, they can be split apart into two separate logs, okay, using subtraction. So multiplication and addition are linked together, subtraction and division. Okay, and then the last one is the power property. So anytime that you have an exponent on your argument, okay, remember the argument is the thing you are taking the log of, okay, that exponent can be dropped to the front and it becomes a coefficient. Okay, so depending on the situation, your properties make it easier for you to solve. So what we're going to do today is actually condense. So we're going to go from the right side of these equations to the left in order to solve log equations. All right, so we saw in Algebra 2 that we can only solve a log equation when there's one log on each side, in which we cancel those out, or if there's a single log in the problem and then we change that into exponential form. Okay, I think that was also on our summer packet for this course. Okay, so if we look here, I can't solve this log equation the way that it's written because I have two logs here on the left. Okay, that means I need to condense them into a single log. So I'm going to be on the lookout for addition, subtraction, and coefficients that I can walk back into condensing using our properties. Okay, so I see that I have subtraction, and I also see that I have a coefficient here. So that coefficient can come back to being an exponent on my expression. So I can change that to be log base 5 of x cubed. Okay, so I'm just kind of doing one thing at a time here. All right, and now this subtraction, I'm going to condense this to be one log. Okay, and again, they have to be the same base, and when you condense, they stay base 5. And now subtraction, okay, is going to condense into me dividing those two values. Okay, well now that I have this condensed where there's just one log on each side of the equation, now I can solve this. Okay, and you don't want to cancel them out before they're condensed, because if you tried to cancel from the very first step, if you just crossed off all the logs, you'd be left with the wrong operations. Because you see, we're not left with subtraction here, and we're not left with like a -4. It turns into a division. So these cancel. I have x cubed over 4 equals 16. Well, this is now just something that I can solve. Okay, so multiply 4 to both sides. X cubed equals 64. And now I'm going to take the cube root of 64. Okay, gets me x equals 4. Okay, you want to just make sure that you take your answer and you plug it back into the problem to make sure that you're not taking the log of a negative or a 0. All right, so I would plug that back in to 3 log base 5 of x. That's the only place we have a variable. Okay, and I plug that back in. That answer looks good because I'm just taking the log of 4. All right, so 4 is my final answer. All right, let's look at another one. So again, I have subtraction. Okay, this is going to condense into one log, and I'm now going to divide those two expressions. All right, well, this is a different situation than the previous problem because I only have one log here. So I need to turn this into an exponential. Write it as an exponent. So 4 to the first power equals 2y minus 2 over y minus 2. So now I'm just going to solve this equation. I'm going to multiply y minus 2 to both sides. This is going to distribute. 4y minus 8 equals 2y minus 2. So now we can solve. Okay, I get y equals 3. Again, check your answer, plug it back into the arguments, and make sure that none of them come out negative or 0. Okay, so this would be log of 4, this would be log of 1. Everything looks to be in order. So y equals 3 is my final answer. Okay, let's keep going. So now you can always do this step by step. And you don't have to condense all the properties at once. So both of those coefficients are going to turn into exponents. So I'm looking at the log base 10 of 6 squared, which is just 36. Log base 10, 27 to the 1/3 power. So the 1/3 power is the same thing as the cube root. So the cube root of 27 is actually 3. Okay, so log base 10 of 36 minus log base 10 of 3. Okay, subtraction turns into division. So I would be doing 36 over 3. Well, 36 divided by 3 is just 12. Okay, so you don't have to condense this all the way down in one step. You could take baby steps. You could even put in here, you could write out 36 over 3. Okay, so now I have one log on each side. I solve that by canceling them out. Okay, and I'm left with 12 equals x. Okay, the only place that has a variable in my argument would be over here on the right side of the equation. If I plug that in, I happen to still be taking the log of a positive number, so this final answer is good. Okay, we got a couple more here. So now I'm looking at addition. So you want to be very careful about the operations here. So I know that you see a minus over here, but that's inside the argument. So we're looking at addition and subtraction of logs, not addition and subtraction inside the argument. So the only operation we actually have in this one is addition. Okay, addition turns into multiplication. So when I condense these, it would be a times a minus 6. Okay, so we can clean that argument up right now. I'm going to distribute. It's going to be a squared minus 6a. All right, so now again, I only have one log here, which means I need to change this into an exponential. So this would be 4 squared equals a squared minus 6a. Okay, so that's the equation we're going to solve. 16 equals a squared minus 6a. So hopefully you see that this is going to have to be factored. I'm going to move 16 to the other side so that it is set equal to 0. Okay, negative 16 and negative 6 is negative 8 and 2. Okay, so I solve those. All right, so I have two answers, but you need to check them. Okay, you're plugging them back in. If I plug in 8, I get log base 4 of 8. Log base 4 of 8 minus 6, which is positive 2. Okay, so 8 works. If I plug in negative 2, I get log base 4 of negative 2. I cannot do that. The argument cannot be negative. It cannot be 0. So negative 2 is not a viable answer. Okay, I still have 8, so that's perfectly fine. If I lost all of my answers, I would say no solution. Okay, we'll do one more here. So the only operation that I see is that coefficient out front, right? Coefficients become exponents. So I'm looking at log base 2 of x cubed, log base 2 of 8. All right, a log on each side means that I cancel. X cubed equals 8. So we're going to cube root each side. And we have x equals 2. Okay, if I plugged that back in, my argument is positive. This answer is good to go. All right, so that is condensing our log equations and then solving. And we looked at both types of equations when you have a log on each side and you have one log. All right, so that is everything that we need to know right now for solving log equations. Please make sure that your notes are complete. And if you have any questions, write those down so we can talk about them in class. All right, that's all for this time, guys. Thank you so much for watching.